So we are looking at parallel and perpendicular lines. So if two lines are parallel to each other, so those two lines are parallel to each other. And clearly, by looking at it, they are going in parallel in the sense they cannot intersect. So the first thing to notice is that two lines that are parallel to each other cannot intersect. They just will keep on going. The second thing to notice is the y-intercept. The y-intercept of two parallel lines have to be different. They can't be the same y-intercept. If they have the same y-intercept, then the lines cannot be parallel. So that is the next remark. So two parallel lines or parallel lines in general will have different y-intercepts, because if they share the same y-intercept, then the lines cannot be parallel to each other. So if you work on a problem and you end up getting two parallel lines with the same y-intercept, then you definitely made a mistake somewhere. The next remark so parallel lines must have or will have the same slope. Naturally, the reason being, if two lines, they don't have the same slope, then they will intersect. What do I mean by that? So you look at the picture, clearly line 2 has a bigger slope than line 1. In other words, the slopes are different. So clearly, if the line extends, you can see that at some point it is going to intersect right over there. So parallel lines must have the same slope, otherwise the lines cannot be parallel to each other. So So anytime we look at parallel lines, we have to keep in mind that they could have different y-intercepts, but they must have the same slope. And then we have the concept of perpendicular lines. So I have three lines, and both it looks perpendicular. So line 2 and line 1 intersect at a right angle, right there. And the same with line 2 and line 1. So both of them intersect the line at right angles. So we can say that line 2 and line 3 are perpendicular to line 1, and it has to intersect at a right angle, because they intersect at a right angle, which means 90 degrees. So clearly, if one line is increasing, the line perpendicular to that line has to be decreasing. So you can see that line 1 has an increasing slope, line 2 and line 3 are perpendicular to line 1, so it is going to have a decreasing slope or a negative slope. So it has to change. So the signs of the slope of two different lines are negatives of each other. So the important remark here is so the negative part one can understand easily because line 1 here has an increasing slope. Line 2 has a decreasing or negative slope. So clearly, if one line has a positive slope, the other, which is perpendicular to that line, will have a negative slope. The reciprocal part requires some advanced math, so I'm not going to get into that in this class. But all you have to realize is if line 1 has a slope of 2, the line perpendicular to it would have negative 1/2 as its slope. In other words, negative of that 2, and you take the reciprocal of negative 2, you get -1/2. So that is something that we have to keep in mind. Another important remark, two perpendicular lines can have the same y-intercept, unlike parallel lines which could never have the same y-intercept. Two perpendicular lines can have the same y-intercept. A clear example is the intersection of line 3 and line 1, right there. That has the same y-intercept. So two parallel lines could never have the same y-intercept. Two perpendicular lines may or may not have the same y-intercept. So if you look at line 2 has a different y-intercept, which is right over here. So I have two lines in each of these problems, and the slope, we've addressed it in the other video. We always have y equals mx plus b. So m is the slope, b is the y-intercept. So I have line 1 and line 2. And the slope for both lines is 12. The y-intercept for line 1 is 6. For line 2, it is -2. So the two lines have same slope, different y-intercepts. This would imply line 1 and line 2 are parallel to each other. In the next problem, we have y equals 2x minus 12 and y equals 1/2 x minus 6. So I'll call that line 1, line 2. The slope of line 1 is 2, which is right here. The slope of line 2 is 1/2, which is right there. And the y-intercept of line 1 is -12, which is right here. You have to include the negative because we have y equals mx plus b as the standard form. And line 2 it is -6. So you look at the two slopes. The slope of line 1 is 2. Slope of line 2 is 1/2. So clearly, slope of line 2 is the reciprocal of the slope of line 1. Yet at the same time, we cannot conclude that the lines are perpendicular to each other, because for them to be perpendicular to each other, the slope of line 2 must be the negative reciprocal of the slope of line 1. So the two lines are neither parallel nor perpendicular to each other. Okay. So the next case, we have two lines again. It may not look like a line. This is what we call the general form of a straight line. The form that we have above is a slope-intercept form, and I'll talk about it when we get to 3.5, I believe, equation of line. When I do that, it should make sense. But for now, just keep in mind that this is the general form of line. So if you want to recognize the slope, it's always better to rewrite the lines in the slope-intercept form, which is right over here, so that we get a clear idea about the slope and the y-intercept. So what do we do first? We do a bit of algebra. So move the 2x to the other side. So I have minus y equals minus 10 minus 2x. And multiply by negative on both sides. So negative times negative y is y. Negative times negative 10 is 10. Negative times negative 2x is positive 2x. Which I could write it as y equals 2x plus 10. It's the same thing. So that is line 1. Line 2, I had to just keep y on the left-hand side. So 4y would equal to 2. 2x moves to the other side. It becomes negative 2x. And 4y would equal to negative 2x plus 2. I'm just rearranging the terms. Divide by 4 on both sides. So 4y over 4 minus 2x over 4 plus 2 over 4, which would give us y. Cancel the 2 out. So we have negative x over 2 plus 1 over 2. If I rewrite this, I could write it as y equals negative 1/2 x plus 1/2. So maybe I'll create a tiny little table here. So this is line 2. So line 1 has a slope of 2. Y-intercept is 10. Line 2 has a slope of negative 1/2. Y-intercept is 1/2. So line 1, or I should write this line 2. Line 2 has a slope, which is negative 1/2. The negative reciprocal of the slope of line 1, which is 2. So the reciprocal of 2 is 1/2. Negative reciprocal simply means negative 1/2. So immediately we can conclude that the lines are perpendicular to each other. So the lines do have different y-intercepts, but we know that perpendicular lines needn't share the same y-intercept. They could have different y-intercepts. So in this case, the y-intercepts do not match, but the slope of one line is the negative reciprocal of another line. And that's what we need to look at when it comes to lines that are perpendicular to each other. So since that condition is satisfied, we can conclude that the lines are perpendicular to each other. So first step is to rewrite it in slope-intercept form. So I'm going to start rewriting it. So line 1, going to move the 2x to the other side. I have positive 2x, negative, and it moves to the other side. It would become positive. Rearranging the terms. Now I divide by 3 on both sides, so y would be equal to 2 over 3x plus 1 over 3. So y would be equal to 2 over 3 times x plus 1 over 3, which means the slope is 2/3 and the y-intercept is 1/3. Line 2, 2y, we keep that on one side, move 3x to the other side, which would give us negative 3x. So we have 12 minus 3x. So 2y would equal minus 3x plus 12. Divide by 2 on both sides. So y would be equal to minus 3 over 2 times x plus 12 over 2. Negative 3 over 2x, 12 divided by 2 is 6. So the slope of line 1 is 2/3. The slope of, the y-intercept of line 1 is 1/3. The slope of line 2 is negative 3 over 2. The y-intercept of line 2 is 6. So clearly the two lines have opposing slopes in terms of signs. One is positive, one is negative. So there is a chance that the lines could be perpendicular. So what is the next condition for them to be perpendicular? The slope must be reciprocals also. So the reciprocal of 2 over 3 is just the flipped version of 2 over 3, which is 3 over 2. So line 2 has a slope which is a negative reciprocal of the slope of line 1. So the two lines are perpendicular. Again, perpendicular lines needn't have the same y-intercept, and parallel lines cannot have the same y-intercept. So in conclusion, can say the lines are perpendicular to each other.